Okay, this is your video for 5.8. This is called special right triangles, and special right triangles is useful now. It's used on the EOC. It'll be used when you get back to pre-cal. It's a very important concept. It's not too difficult, but some things can get confusing because there's kind of X's all over the place. So you may want to grab either a different color pen or a highlighter to kind of help you distinguish the difference. Okay, the first special right triangle is originated from a square. So this is a square, all four sides are the same, all the angles are right angles. When I draw in one of the diagonals, I still have my right angle, but now these two are two congruent angles that I cut in half. So they used to be 90, but I cut them in half, so now they're both 45. So what you can notice about this is an isosceles right triangle. The two of the sides are the same, therefore two of the angles are the same, so they both have to be 45. So this is our first special right triangle, and it is just called exactly what it is, a 45, 45, 90 triangle. Now the formula for 45, 45, 90 is going to look like this. 45, 45, 90, x, x, x on the square root of 2. So what that means is across from the side that is a 45, we're going to put an x. We're going to do like a proportion. Across from the other 45, obviously, is going to be the same thing, because if the angles are the same, then the sides are the same. And across the 90, the hypotenuse is going to be x on the square root of 2. So what's going to happen is they're going to tell you in some way or the other, either by telling you it's isosceles or telling you it's 45 something, they're going to tell you that this is a 45, 45, 90 triangle. Then they're going to give you one of these sides. Say this side is 7. Then you're just going to fill in the blanks. 7, 7, 7 on the square root of 2. It's going to be very easy if you just kind of hold on. Okay, so let's look here. So this, one thing you want to look for is always that this is a right triangle. Then indicate some way that it's a 45, 45, 90. So this is 45 degrees, so this must also be 45 degrees. Now where this gets a little confused is this x is the x from the problem, like, hey guys, find x. But we also have x's from our formula, so you want to keep those separated. That's why I said maybe two colors is helpful. Okay, so the first thing you want to do is in your different color pen, you want to mark the formula. Across from 45 we put x, across from 45 we put x, across from 90 we put x on the square root of 2. So that's why this is confusing, because these are the sides are x are from the sides of the formula, but this x is from, hey, find this side please. So if you want to change this, say, hey, find P or find Q or find whatever, so you don't get confused, that's fine. Okay, so they're always going to give you at least one side, and that's where you start. Well, right here, I know that x is equal to 8. So if this is 8, this is also x, so this side over here is also 8. And then you go and plug in over here. X is 8, so all I have to do is say, oh, then this is 8 on the square root of 2. Done. You don't have to do any simplifying or any solving in this one. It's just 8, 8, 8 on the square root of 2. Okay, let's move over to B right here. Okay, this one, I know it's a right triangle. I also know that it's isosceles because this side and this side are both x, so this must be congruent. So therefore, I know this is a 45, 45, 90 triangle. Now this one's a little less confusing because the sides that we would have marked x in our formula, across from 45 goes x, across from 45 goes x, were already marked x. So it's not near as confusing as the last one was. So across from the 90 degrees goes x on the square root of 2. Now, this is our formula right here. X on the square root of 2 is equal to 5. Okay, so we need to solve this. X on the square root of 2 is equal to 5. Okay, so we're going to divide by the square root of 2 to get that off. Just like if it were 3x, you divide by 3. If it were 10x, you divide by 10. It's x on the square root of 2, so I'm going to divide both sides by the square root of 2. So x is equal to 5 over the square root of 2. Now, I don't know how much you remember from Algebra 1, hopefully a lot, but if you don't, pay close attention. Remember, you're not allowed to leave the square root in the bottom because that's against the rules. So what you do is you multiply both the top and the bottom by whatever is in the bottom. So square root of 2 is the problem, that's what I want to get rid of, so I'm going to multiply by square root of 2. But if I do it to the bottom, I have to do it to the top to keep it even. Okay, now just like you're multiplying fractions, you just multiply straight across. So 5 times the square root of 2 is 5 on the square root of 2. Square root of 2 times itself. Now anytime you multiply a square root by itself, what you end up getting is the number inside, because this square root of 2 times square root of 2 is square root of 2 squared, because anything times itself is just that number squared. And we've already talked about a square and a square root are opposites of each other, so they cancel each other out and they leave you just with what was inside. That is the reason we chose to multiply by square root of 2, so that it would be nice and easy. Square root of 2 times square root of 2, forget the square roots, and that just leaves you with a 2. So this is your final answer there. Okay, if you've forgotten how to rationalize, that's what this is called, rationalize. Don't worry, we'll work on it a lot tomorrow, so you'll remember and you'll get good at it. Okay, y'all pause and try C. Okay, so C is x on the square root of 2. So in this case, they told me x was 10 on the square root of 2. But I wanted to find what was in my formula for x on the square root of 2. So what I had to do was 10 on the square root of 2 on the square root of 2. Does that make sense? Because x already had a square root of 2 in it, and I needed another one. So I wanted 10 on the square root of 2 on the square root of 2. So we just talked about this. What happens with square root of 2 times square root of 2? The square roots cancel out and you just get 2. So 10 times 2 is 20. Okay, you're going to have a square root of 2 most 9 times out of 10 somewhere in the problem. So if they didn't give you a square root of 2, your answer probably will be a square root of 2. If they didn't give you a square root of 2, your answer will probably have a square root of 2. In this case, they gave me a square root of 2, so my answer will probably not have one. Okay, so that's 45, 45, 90s. Oh, let's do a word problem. Okay, so Jana is cutting a square of a material for a tablecloth. So I'm going to stop and label square. The table's diagonal is 36 inches, and she wants the diagonal of the tablecloth to be an extra 10 inches so that it will hang over the edge of the table. What size square should Jana cut to make the tablecloth? So I want the diagonal to be 46. Now I know this is a square, so I know it's an isosceles right triangle, so I know it is 45, 45, 90. So let's put our formula. Across from 45 goes x, across from 45 goes x, across from 90 goes x on the square root of 2. And then you can see that is where our little formula, our little equation is going to come from. X on the square root of 2 is equal to 46. Divide by square root of 2. Divide by square root of 2. Now the beauty of this is that this is a word problem, so that we can use a decimal instead. So I can just go on my calculator and type 46 divided by the square root of 2. And I want to round to the nearest inch, so that will be 33 inches when I go and type that in. So you start to like word problems a little more when you realize that means you don't have to do a radical. Okay, so that's 45, 45, 90s. The other kind of special right triangles is derived from an equilateral triangle. So that means all the sides are the same, and I'm going to draw in a perpendicular bisector. Now bisector, remember, means that this side is going to be cut in half. Perpendicular means that these are going to be right angles down here. Okay, now this was an equilateral triangle before, so these angles are 60 degrees. This whole angle was 60 degrees, and then I bisected it So this is going to be 30, and that is going to be 30. So that's why this new special triangle that's derived from an equilateral triangle is called a 30, 60, 90 triangle. Okay, so let's look at the formula here. 30, 60, 90, across from 30 goes x, across from 60 goes x on the square root of 3. So 45, 45, 90s have x on the square root of 2's. 30, 60, 90s have x's on the square root of 3. And then across from 90 goes 2x. So here's a little triangle all the way drawn out. 30, 60, 90, across from 30 goes x. Across from 60 goes x on the square root of 3. And across from 90 goes 2x. Okay, again, they have to tell you this is a 30, 60, 90 triangle. You can't just assume. Okay, so here's this one. So across from 30 goes x. Now luckily that's not confusing. They already had x. Across from 60 is x on the square root of 3. And across from 90 is 2x. Okay, here is my equation based on the side they gave me. 2x is equal to 22. Therefore, x is equal to 11. And this side would be 11 on the square root of 3. No work necessary for that one, not much anyway. If this is 22, this is half of that, which is 11. 11 on the square root of 3. Okay. Whoops. Alright, give me 1 second here. Okay, let's do B. So this is a 30, 60, 90 triangle. So across from 30 goes x. Across from 60 goes x on the square root of 3, and across from 90 goes 2x. Okay, here's my equation. X on the square root of 3 is equal to 15. Divide by square root of 3. X is equal to 15 divided by the square root of 3. Now this is where we're going to rationalize like we did on that 45, 45, 90. Whatever's in the bottom, that's what you want to get rid of, so you multiply it by itself. If you do it on the bottom, you have to do it on the top to keep everything balanced. Then you just multiply straight across. 15 times the square root of 3 is just 15 on the square root of 3. Square root of 3 times itself, the square roots cancel out and just leave you with plain old 3. Now look here, you have 15 over 3, so you can simplify 5 on the square root of 3. Okay, all I did was divide 15 by 3, and then I just held on to my square root of 3 there. Okay, so x is equal to 5 on the square root of 3. Now y is 2x, so I just need to multiply this by 2. So 5 on the square root of 3 times 2, all you do is multiply the outside numbers together. So that would be 10 on the square root of 3. Multiplying with radicals is just like multiplying, like if I told you to multiply 3 times 4x, you would do 3 times 4 is 12, and then you would just drag the x along with you. This is the same thing. 5 times 2 is 10, and then just drag the square root of 3 along with you. Okay? An ornamental pen is in the shape of an equilateral triangle. Draw and label. The length of each side is 6 centimeters, and Josh will attach a fastener to the back along AB. So basically he's going to glue a safety pin right along the middle right here. Will the fastener fit if it is 4 centimeters long? So this is an equilateral triangle, so this is 6, 6, and 6. When I cut this bottom side in half, I'm going to do 3 and 3. So that way this becomes a 30, 60, 90 triangle. So I'm going to redraw this without the other stuff included just to make it easier to see. This is 3, this is 4, this is 6. So I need to figure out, is this 4, how is this going to relate? So I'm going to find the actual length here, and then I will compare. So across from 30, I put x. Across from 60, I put x on the square root of 3. Across from 90, I put 2x. Now this is really already done. X is 3, 2x is 6, so I'm just going to use the easier one. So if x is 3, then what I'm interested in is what is 3 on the square root of 3. So let's just go type that into our calculator. The square root of 3 is 1.73 times 3. That is 5.2. Okay, so here now we figured out that the height of this thing from top to bottom is 5.2. So what we need to ask is, will the fastener fit? So if the whole pin is 5.2, but the safety pin is only 4, then yes, it will fit. There will be a little bit on top and a little bit on bottom left over, but that's good. You'd rather some be left over than the safety pin be sticking out behind your pin. Nobody wants that. Okay, see you tomorrow.